Alright guys, so for part 2, we actually just answered number 5. So it says make a staircase. One more time, let's look at the staircase. In orange, it was the 5 over 5 with a height of 25. Second staircase had a height of 20, which had the ratio 6 over 4. And the final one had a staircase of 15, which is actually the second staircase of a height of 15. There's actually a mistake that I did here. So if you look at your previous one, this staircase 2 was purple. Staircase 2 had a height of 15, while staircase 3 had a height of 20. Sorry about that. Okay, so let's go ahead and jump right into it. It says, what is the rate of change for each line? How does the rate of change relate to the rise over run? Well, I wanted you to notice for table 1, we had 0, 0, 5, 5, 10, 10, 15, 15, so on and so forth. So here's your X, here's your Y, 20, 20, and 25, 25. This is for the first staircase where we had a rise over run of over 5. And I want you to notice I am always changing by 5 on each and every one. So remember, the ratio for rate of change was your change in Y. So I'm going to put delta Y, which just means change, and change in X, and that was 5 over 5. Now on the second one, where I had a rise of 3 and a run of 8, that looked like 0, 0, and then here's my X, here's my Y. It went up to 3, 8, 6, 16, 9, 24, 12, 32, and 15, 40. And I want you to see, same idea. Remember, I want to see what the change in Y over the change of X is. So it's just the difference, how much each one is increasing. And as you can see, my Y values are each increasing by 8, and my X in values are changing by 3. I want you to notice on both of these, I do not have a unit rate. A unit rate has a 1 on the denominator. This is a rate of change. Remember, how much is your Y changing by how much your X is changing? That's the ratio. And if we did the same for the third staircase, it would have a rise over run of 6 over 4. And so when it says, what is the rate of change for each line? How does the rate of change relate to the rise over run? They are the same. So number 6, I want you to write the rate of change is equal to rise over run. So how much I went up and how much I went over. So now what you're going to see me start writing is the ratio right here in purple. Whenever I'm talking about rate of change, you're also going to hear me say rise over run, because we just shown, you guys just discovered that rise over run is equivalent to the rate of change. So number 7, when a linear relationship is graphed, how is the constant rate of change represented? Well, as you guys just saw, it is represented through the rise over run proportion. Or excuse me, the ratio. So the rise over run is represented or I should say represents the rate of change. So for instance, anytime you'll also have just learned this is the slope of a line. Some of you might have heard that word slope, some of you may not have not, and that's okay. So I just want you guys to realize that slope is equivalent to rise over run, which is also equivalent to rate of change. So anytime I say any of these words, they're all the same for one particular line. All right. So the next thing is, though, remember, ratios can be simplified. So find the slope of each line representing the staircase. Simplify your ratio. So if we look, staircase was 5 over 5, which simplifies to 1 over 1, which is equivalent to just 1. Staircase number 2 was 3 over 8. This staircase does not simplify anymore, so it is just 3 over 8, and you don't even need the second one. You could just leave 3 over 8. And the last one, let me just double check. Yes, it was 4 over 6. And the numerator and denominator could both be reduced by 2, which will give you 2 over 3. And remember, these ratios all are comparing how much do I rise, how much do I go up, versus how much do I run. That's how much do I go over. So if that helps, I'll write that in blue. How much do I go up or down compared to how much I go left or right. That's just another way for you guys to visualize it if rise over run's a little confusing. So if you didn't have the graph to look at and could only examine the ratios we just calculated, how would you know which staircase is the steepest? So remember, our ratios were 1 over 1. These are the simplified versions. We had 3 over 8. And we had 4 over 6, which simplified to 2 over 3. So if I compare these numbers just as regular old integers, I noticed that this was the greatest number. Had the greatest value. This was the second greatest value. Followed by 3/8 is the third greatest value. So it's the smallest. Now I want you to notice when you look at those slopes of 1 over 1, 3 over 8, and 2 over 3, what had the greatest slope? Well, it ended up being this one right here, 1 over 1. 1 over 1 was the greatest number, the greatest value of a number, and it also had the steepest slope. My third was 2 over, my third staircase, 2 over 3, was the second steepest, and 2 over 3 is the second greatest value. So it's a little smaller than 1, but it's a little bigger than 3/8. So that's why it was second. And finally, 3/8, which was my smallest value, that was also my least steepest. One thing I want to keep in mind is it's not the biggest or greatest number, because as we're going to be looking into the future, if you have a very large negative number, it may be steeper than a positive number. So we're looking at the actual value, not at what's the largest number. So for instance, -10 versus +1. And we'll touch on that in the future. So when it says, how would you know which is the steepest? What we could write here is the number with the greatest value will be my steepest slope, my steepest staircase. Sorry, the number with the greatest value will have the steepest staircase. All right. So let's go ahead and look at this. We're going to calculate the slope for climbing 1, 2, 3 on each staircase. So let's go ahead and look at this. On step 1, I went up 5 and over 5. So before we continue, I just want you guys to realize that what we are going to do is we are going to be comparing the ratios of change in y over change in x, and we're going to compare those ratios for each and every step to see what we get. So the rise over run would be 5 over 5, which is equivalent to 1 over 1. All right. Second step, I went up to step 10, and I would go over 10, which would be 10 over 10. which also simplifies to 1 over 1. And finally, step 3 would be 15 over 15, which would give, excuse me, let me take that a step back. Okay, 15, which means I would have 15 over 15 for my rise over run, which would be 1 over 1. Now I want you to notice that my rate of change, how much I go up and over, has a consistent ratio, a constant ratio of 1 over 1. That is how you know this is a linear equation, because the constant rate continues to increase for each one. Now, I'd like you to pause it right here and fill in the second two tables on number 10. Please unpause it when you're done and double check your answers with me. So go ahead and pause it right now. Alright guys, if you're watching this part of the video, you should be done. So remember, on the next staircase, what we did is we looked at staircase 2, which had me go up 3 over 8. So let's see, total rise, I went up 3 and over 8, which is just 3 over 8. It doesn't simplify to anything. The next staircase, I would go up additional 3 spots to 6. And for my run, I would go over an additional 8, which would be 16. So remember, we're looking at rise over 1, which is change in y over change in x. That would be 6 over 16, which is equivalent to the ratio 3 over 8. And finally, my third step would be 3 more up, which is 9. 8 more over, which would be 24. And if I were to write that as a ratio, 9 over 24 would be equivalent to 3 over 8. Remember, this is called the rate of change. I want you guys to notice this is not unit rate because I do not have a 1 on the denominator. I'm not increasing by 1, but instead I'm going up 3 over 8. So all this slope, this rise over run, also known as the rate of change, and they are all equivalent, rate of change. Awesome. All right, so let's look at our third and final step. We'll go ahead and do this one in purple. My third and final step, remember I went up 4 and over 6. So that would just be 4 over 6 for my rise over run, which would be 2 over 3. Same idea here. Now we're going to go up 4 on step 2 and over 6 to get 12, which would be 8 over 12, which would be equivalent, if I simplified the numerator and the denominator by 4, would be 2 over 3. And then this would be up 12 over 6 would be 18. Same idea, 12 over 18 would simplify to 2 over 3. So I just want you guys to realize this is my slope, which is equivalent to the rate of change, and it is 2/3. So since my slope is 2/3, I know that it is a linear equation because it has a constant rate of change. Alright guys, so go ahead and we're going to watch the final video. So goodbye.